Welcome to my class Introduction. Class Standard 9, Subject Higher Mathematics, Chapter name Algebraic Expression, Exercise 2, Lecture 2. Today's lesson to explain multiplication, division and identity. Multiplication and division of polynomial. Addition, subtraction and multiplication of two polynomials is always polynomial, but division of polynomial may or may not be polynomial. For example, if we divide x by x cube, take the answer as x to the power minus 2. This is not polynomial because here power is negative, but for polynomial power will be non-negative. So this is not polynomial. But when result as 0, that means quotient 0 and remainder x, then it is polynomial because this is not non-negative integral power, this is constant. Okay, here constant power will be 0, that's mean non-negative, so this is polynomial. Clear? Example, what is the result of the multiplication of x square plus 2 and x plus 1? Here degree of this expression is 2 and here 1, and 2 plus 1 mean 3, so the degree will be 3 after multiplication of these two term, and leading coefficient will be 1 into 1, that's mean coefficient of x square this equal to 1, and here also coefficient of x this equal to 1, that's mean 1 into 1 this equal to 1, so leading coefficient will be 1. And we know how to multiply because from class 7 we had learned how to multiply and divide. Clear? This into this will get x cube plus x square plus 2x plus 1. Degree will be 3. Leading coefficient will be 1. From here we can also say degree will be 2 plus 1 this equal to 3, and leading coefficient 1 into 1 this equal to also equal to 1. Clear? By applying this you can easily solve like this of math. Division algorithm. P of x and q of x are two polynomials of the variable x, and degree of q of x is less than p of x. We can divide p of x by q of x in usual manner, and we obtain a quotient f of x and remainder r of x. As we divide p of x by q of x, so p of x this is a dividend, q of x this is a divisor, and here f of x and r of x are remainder, and this will be quotient. Clear? Both f of x and r of x are the polynomial of the variable x, that's mean quotient and remainder both are polynomial in this condition. Okay, and degree of f of x this equal to degree of p of x minus degree of q of x, that's mean degree of quotient this equal to degree of dividend minus degree of divisor, and the remainder will be either 0 or less than a degree of r of x less than degree of q of x, that's mean degree of remainder less than degree of divisor, and dividend this equal to quotient into divisor plus remainder. Okay. Example 3. What is the quotient when x square plus 1 into x minus 6 is divided by 2x square plus 3? Here dividend p of x this equal to this into this, and this equal to this we know, with degree here 3 and leading coefficient that is equal to 1, and divisor q of x this equal to 2x square plus 3 with a degree 2 and leading coefficient 2. So degree of this 3 and degree of this will be also 2, and coefficient here 1, but here is 2. So when we divide this by this, we get quotient will be half of x minus 3 and remainder r of x, this equal to minus x by 2 plus 3. After divide this by this, we'll get quotient this and remainder this, and we know how to divide. So I don't discuss about the division because from class 7 you know how to divide. Okay, hence quotient f of x is polynomial with degree 1 and leading coefficient that is equal to half. Now identity, if the two polynomials p of x and q of x for all x are equal, their equality is called the referred to as identity of the polynomials. Sometimes this is indicated by writing p of x identity q of x. In this case, the two polynomials p of x and q of x are the same. The sign this is called identity sign. Generally, the equality of the two algebraic expressions is called the identity. If the domain of any one variable of the two expressions is the same, and for the values included in the domain of the variables, the values of the two expressions are equal. For example, x into x minus x plus 2, this equal to x square plus 2 into x. That's mean when we'll put x is equal to 2. So here will be 2 into 2 plus 2. That's mean 2 into 4. Result will be 8. Here 2 is mean 4. Here 2 into 2 mean 4. That's mean 4 plus 4. This equal to 8. That's mean left hand side, right hand side same. Here also same. Both are identity. Clear? Remember the theorem. Here follow p of x is a polynomial of positive degree and a is any fixed or definite number or constant. The remainder of the division of p of x by x minus a will be p of a. Proof, if we divide this by x minus a, the remainder is either 0 or non-zero constant. Suppose the remainder is r and quotient is q of x, then by law of division for all x, p of x this equal to divisor into quotient plus remainder. But when we'll put x is equal to a, then we'll get p of a this equal to 0 into q of a plus r this equal to r. Therefore, the remainder of p of x upon division by x minus a is p of a. Clear, everyone? By applying remainder theorem, we can easily solve this type of math. Here given p of x this equal to x square minus 5x plus 6 divided p of x by x minus 4, so that the remainder is equal to p of 4. After dividing this by x minus 4, remainder will be 2. Also, when we'll put x is equal to 4, here also 4 square minus 5 into 4 plus 6, result will be also 2. That's mean p of 4 this equal to 2, also remainder 2. So p of 4 is a remainder. Clear? Same math, another example 5 number. P of x this equal to x cube plus bx plus c divided p of x by x minus m, and show that the remainder is equal to p of m. After dividing this by this, remainder will be this. Okay, and also when we'll put x is equal to m, here will be a into m cube plus b into m plus c. That's mean this and this same. As this is remainder, so p of m also remainder. So proof is complete. Very easy math. Clear, everyone? Proposition theory, factor theorem. That's mean in this case, remainder, if remainder 0, first part same, But if remainder 0, that's mean P of A is equal to 0, then x minus A is a factor of this polynomial P of X. Okay, the remainder of P of X upon division by x minus A is P of A is equal to 0 given. This means the polynomial P of X is divisible by x minus A. Therefore, x minus A is a factor of the polynomial P of X. Another converse factor theorem. Here, if P of A is equal to 0, then x minus A is a factor of P of X. Converse means when x minus A is a factor of polynomial P of X, we can say P of A is equal to 0. That means remainder 0. This is a converse of factor theorem. This is a factor of polynomial this, then P of A is equal to 0. But factor theorem means if P of A is equal to 0, then x minus A is a factor of P of X. But here, if x minus A is a factor of polynomial P of X, we can say P of A, that's mean remainder this is equal to 0. Proof, since x minus A is a factor of P of X, there exists a polynomial Q of X, that P of X is equal to x minus A into Q of X. Putting x equal to 0, P of A is equal to A minus into QA, this equal to 0 into QA, this equal to 0. So proof is complete. Clear everyone? Follow this theorem, we can prove example 10, show that x minus 1 will be a factor of P of X. This equal to x cube plus b x square plus cx plus d if and only if a plus b plus c plus d is equal to 0. Solution, suppose a plus b plus c plus d is equal to 0, then P of 1 is equal to a plus b plus c plus d is equal to 0 by condition. When we'll put here x is equal to 1, x is equal to 1, then we'll get here a plus b plus c plus d as a plus b plus c plus d is equal to 0. So P of 1 is equal to 0. As P of 1 is equal to 0, so we can say x minus 1 is a polynomial. Clear everyone? By factor theorem. Again, now let's assume x minus 1 is a factor of P of X. As here is given if and only if. If and only if mean when this equal to 0, we can say x minus 1 is a polynomial factor of this polynomial, and when x minus 1 is a factor of this polynomial, we can prove a plus b plus c plus d is equal to 0. Clear? That is a if and only if. X minus 1 is a factor of P of X. So by the converse of factor theorem, we get P of 1 this equal to 0. Converse factor theorem mean P of 1, as here is one fixed number 0, that's mean remainder 0. So we can say P of 1 mean a plus b plus c plus d, that's mean x is equal to 1, 1 cube mean 1, so here will be a plus b plus c and right side will be 0. Proof is complete. Clear everyone? Follow the lecture properly. When everyone follow the lecture properly, you can easily solve 1, 2, 3, 4, 5, 6 and 7 number math. Okay, and also you can solve in your book exercise 2, 1 up to 6 number. Okay, now follow the example 13. Resolve into factors 18x cube plus 15x square minus x minus 2. At first you have to let P of x is equal to 18x cube plus 15x square minus x minus 2. Okay, and you have to put the value of x as a result. Here will be value of this term will be 0. Okay, when we put x is equal to minus half, the result here will be 18 minus 1 by 8 plus 15 into 1 by 4, because here is x square plus 1 by 2 minus 2, this equal to 0. As p of minus half this equal to 0, so x plus 1 by half or 2x plus 1, that will be the factor of this polynomial. That's mean follow here. Therefore x plus 1 by x, as here is minus, so here will be plus. If here is plus, here will be minus, equal to this, or that is 2x plus 1 is a factor of p of x. Now 18x cube plus 15x square minus x minus 2, this equal to, at first we have to write 2x plus 1 into 2x plus 1 into 2x plus 1, as here is 18x cube but here is 2x, so we have to take here 9x square, and 9x square into 2x, this equal to 18x cube. 9x square plus 1, this equal to 9x square, but here is 15x square, so we have to take, as here is 2, so we have to take here is 3x. As a result, 3x into 2x, this equal to 6x square, and 6x square plus 9x square, this equal to 15x square. So this equal to, we can write 9x square plus 6x square, and 3x into 3 mean 3x. Okay, as here is 2x plus 1, but here is minus x, here is minus x, as here is plus 3x, so we have to take here minus 4x. As a result, plus 3x minus 4x, that's equal to minus x. So for matching this, we have to take here 2. As a result, minus 2 into 2x, that's equal to 7, minus 4x, minus 2. This equal to 2x plus 1 into 9x square plus 3x minus 2. That's mean here is 2x plus 1 is common. So here will be 9x square plus 3x minus 2. Clear? Again 9x square plus 3x minus 2. This equal to, here is middle factor, 9x square plus 6x minus 3x minus 2. And between these two, we can take common 3x. As a result, here will be 3x plus 2. And we can take here common minus 1. As a result, here will be 3x plus 2. As a result, here will be 3x plus 2 into 3x minus 2. And therefore, we can write p of x this equal to 2x plus 1 into 3x plus 2 into 3x minus 1. Okay. Another problem. Resolve into factors. Minus 3x square minus 2xy plus 8y square plus 11x minus 8y minus 6 into factors. Here two parts are quadratic. Here is x square, here also x square, y square, and here xy, but here is only x and only y. So we have to take at first the term of x and the term of y. That's mean, follow the solution here. Considering only the terms of x and constant, here will be minus 3x square plus 11x minus 6, and resolve into factors. This equal to, we can write minus 3x plus 2 into x minus 3, or we can write 3x minus 2 into minus x plus 3. No problem. Again, only considering the term y and constant term. Here will be 8y square minus 8y minus 6. Here constant term minus 6, here also constant term minus 6. So we have to take constant term are fixed. That's mean here is constant term plus 2. So we have to take here also plus 2. Here minus 3, we have to take minus 3. As here is minus 2, so here will be minus 2. Here plus 3, so we have to take here plus 3. Okay, that's mean constant term will be same, because we have to take here minus 6, also here minus 6. And after resolve this part, we'll get 4y plus 2 into 2y minus 3, or this equal to, we can write this minus 4y minus 2 minus 2y plus 3. That's mean after taking common here minus, also here minus, result will be this, no problem. So the required solution will be minus 3x plus 4y plus 2 into x plus 2y minus 3, or we can write 3x minus 4y minus 2, or minus x minus 2y plus 3. Both are correct, no problem. You can take any one of this. Clear everyone? Follow this, you can easily solve the problem 7 in your book exercise 2, and there is given 8 math. That means 7 1 7 2 7 3 7 4 7 5 7 6 7 7 7 8. So up to 7 8, that will be homework. So everybody will solve properly and submit the copy in the group. Date of submission 7/3/2021. So today after this, thank you to all everyone.